Alright, so we got this weightlifting thing here, where we have the weight class in, and it's in kilograms, and then how much weight they lifted. So put that in a calculator, right? And then we go to stat plot. We can do L1 versus L2, and we do zoom stat, and I could see already it's curved. It says here to check the residual plot. Is your linear model appropriate? And B, I don't have to check the residual. I mean, we can if you create a linear model. So, well, let's go ahead and do it for the sake of doing it, but I know it's already going to be curved. I'm already looking at it. So, all right, so let's go to stat calc number 8, enter, and then we're going to go to the residual plot. And we go to list residual, and then we're going to go to zoom 9, and there it is. There's a curve, right? It goes up like that and down like that. Okay, so it's curved. So linear model is not appropriate. Okay, so let's go back to the original plot. And now, in this case, do you guys see how it's bent this way? So this is bent this way, right? So I got to go up the ladder of powers. So I'm here, I got to go this way. So I'm going to start out by squaring L2 to begin with. So let's see what happens. If not, then I know I got to go to attack of the logarithm. So L2 squared. So that's where we're at. So let's go to L1 versus L3. And let's see what happens with that. Seems like it's decent. Okay, so let's go look at this, number 8, and we're going to do L1 versus L3. Okay, so A is, so we got y equals a plus bx. A is negative 1089.43. B is 1762.57. And R squared is 0.982, and R is 0.991. Okay. So now you know, what does the residual plot look like here? Well, let's see. Still shows kind of a curve, right? So let's see if we can't check some of our other models. Let's see if some of our other models don't work. So I'm going to go to attack of the logarithms. So I'm going to do log of x, right? So I'm going to do log of L1. And then in my calculator, I'm going to do, my new x variable is going to be L3 versus L2. Okay? Now, that's not too bad. Okay? But now, there's, well, looks like it still could be a little bit curved, but that's not too bad. So let's see what happens if we check the residual plot there. We're going to do linear regression, and we're going to do L3 versus L2, and that's the model we get. And then I want to just check this residual plot. So I'm going to do L3 versus residual, and let's see what happens. Yeah, that's not too bad. Okay, that's fairly random. Okay, so I like this model. This model seems to work pretty well. I was going to go to log, but I'm not going to. This seems to be fine. So again, this we went to attack of the logarithm now. Okay, well, let's see what log looks like. So we're going to do log of L2. So the L3 is log of L1, L4 is log of L2. So when we go to stop plot, we're going to do L3 versus L4. And that's more curved, so I don't like that. Alright, so the one that I like is just log of X, which is an L3, versus Y. So I'm going to say, okay, calculator, let's calculate L3 versus L2. Okay, so in this case, we got y equals a plus bx. We got a equals negative 451.19. B is 434.68. R squared is 0.989, and R is 0.994. So what did we do? Okay, well, what we did is to predicted weight lifted equals negative 451.19 plus 434.68 times what? Times the log of the weight class. So that's basically what that one came out to. Okay? So that one would be, that right there would be the best model.